Then the next important technique is cluster analysis. So clustering is the task of dividing the unlabeled data or data points into different clusters such that similar data points fall in the same cluster than those which differ from the others. So in simple words, the aim of the clustering process is to segregate groups with similar traits and assign them into clusters. Clustering describes the method of aggregating data that shares similar attributes. Consider a large online retailer like Amazon. Amazon can cluster sales based on the quantity purchased, or it can cluster sales based on the average account age of its customer. So by separating data into similar groups based on the shared feature, analysts may be able to identify other characteristics that define future activity. There are types of clustering now. Broadly speaking, clustering can be divided into two subgroups, hard clustering and soft clustering. In this, each input data point either belongs to cluster completely or not. For example, in the above example, each customer is put into one group out of 10 groups for Amazon. So in this, instead of putting each input data into separate cluster, a probability or likelihood of data point being into those clusters is assigned. For example, from the above scenario, each customer is assigned a probability to be in the either of the 10 clusters of the retail store. Now, different types of cluster algorithms. Connectivity model. So as the name suggests, this model are based on the notions that the data point closer in data space exhibit more similarity to each other than the data points lying farther away. These models can follow two approaches. In the first approach, they start by classifying all data points into separate cluster and then aggregating them as the distance decreases. In the second approach, all data points are classified as a single cluster and then partitioned as the distance increases. Also, the choice of distance functions is subjective. These models are very easy to interpret, but lack scalability for handling big data sets. Examples of these models are hierarchical clustering algorithms and their variants. Then is centroid models. These are iterative clustering algorithms in which the notions of similarity is derived by the closeness of a data point to the centroid or cluster center of the clusters. Now, the k-means clustering algorithm is a popular algorithm that falls into this category. In these models, the number of cluster parameters required at the end has to be mentioned beforehand, which then makes it important to have prior knowledge of the data set. These models run iteratively to find a local optimum. Next is distribution model. Now, this clustering method plays a vital role and are based on the notion of how probable it is that all data points in the cluster belong to the same distribution. This model often suffer from overfitting. A popular example of these model is the expectation maximization algorithm, which uses multivariate normal distribution. Then is density models. These models search the data space for areas of the varied density of data points in the data space. Now, here what happens is they isolate different dense regions and then assign the data points within these regions to the same cluster. Popular example of density models are optics and deep scan, DB scan. These models are particularly useful for identifying clusters of arbitrary shape and detecting outliers, as they can detect and separate points that are located in sparse region of the data space, as well as points that belong to dense region. Now, application of clustering. Clustering has a large number of applications spread across various domains. Some of the most popular applications of clustering are recommendation engines, market segmentation, social network analysis, search result grouping, medical imaging, image segmentation, and anomaly detection.